Thank you very much for coming back to the keynote session of this year's Photonics Plus. Just before summer, we are getting to know each other better and we are reconnecting with the industry. Femtosecond and nanosecond lasers are making a huge impact on surface structuring. We are seeing now aquaphobic, antibacterial surfaces being deployed at real environments. We can't be more excited about this. I wanted to bring today the key success story that we have in EPIC on deploying this technology in real use cases. We are going to go all the way to beautiful Barcelona and meet the CEO of the company MICRORELLEUS, Raúl García. Buenas tardes. Thank you very much for being a keynote speaker at this session.
Hola, buenas tardes, Jose. Thank you so much. I will share my screen. Can you see it? Can you see my screen, Jose?
Raúl, we see it clearly, the floor and the attention of everyone on this global event goes to you.
Thank you so much. And again, Jose, thank you so much for your introduction. It's always a pleasure to be here and to see you. And as Jose said, I am Raúl García, the CEO of MICRORELLEUS in Barcelona. And today I will speak about microstructuring and texturing applications in industry, both in mold and on final part, using femtosecond and nanosecond lasers. So I will speak just 1 minute about who we are, what we do, and then we are going to focus directly to speak about the nanosecond laser texturing, that we are using it to apply design texturing on molds mainly to make the final plastic part more beautiful. And then I will speak also again about applications for the femtosecond laser. In this case, functional texturing. We will see why we need femtosecond laser for most of the applications of functional texturing, and also laser microstructuring. So that's our company. That's who we are. We are a workshop. We are a service company that we provide the service of the industrial engraving, laser texturing, and laser microstructuring. We're in the market since 1983. We are placed in Barcelona, and we are offering nanosecond laser in 5-axis service since 2013, and femtosecond laser service in 5-axis since 2016. So it's some time ago right now. So if we speak about laser texturing, as I told before, both speaking about engraving the mold or the final part, we can separate between design, just to make a product more beautiful, or functional, to add some properties to a product just because of the microstructure of the microtexture that we apply mainly in the mold. Then the plastic is injected, replicates the nanostructure, microstructure, microtexture, and because of this replication, it achieves some properties that we will see later. So why it is so important nowadays, the laser texturing for design texturing, in this case using nanosecond lasers? Because it is an alternative to the standard chemical etching engraving since long time ago, and it has a lot of advantages against it. In terms of design, there is new possibilities. In fact, we can engrave whatever it is possible to design. It is environmentally friendly, perfect repeatability, definition, and quality. We can see here some examples where we can see even morphing of textures, for example. And the laser is removing material layer by layer. We have to understand it like a milling machine, that instead of a spindle, we have a laser source, laser head there. So the machine is making all the mechanical movements, and the laser is engraving where we programmed it. So laser removes material layer by layer. In each layer, we can remove less than 1 micron if we want. So more layers, more definition. If we compare it with chemical etching, for example, where they use 3, 4, 5 layers, we can use hundreds of them. So the definition, the quality is much more natural, much more with higher, better quality. So we work the textures in grayscale from 3D CAD file, Photoshop, 3D scanner, for example. And in the grayscale image, darker means deeper. So we can see here in this image the 2D representation and what we are going to achieve in the part in the 3D result. Let's put an example about it. So here we have the initial data, what we need, what it is necessary, the grayscale, the texture that we want to apply somewhere, and we need also the cut file of the mold, in this case, the mold insert, the tool insert, and then what we do is we take the surface where to engrave, and we do the mapping mesh. Then we put the texture over the mapping mesh and have a render. So we are going to have an image of what we are going to have finally. Then everything is post-processed with the machine. Machine understands this image and this grayscale level, taking into consideration how many material we are removing on each laser layer. And then we engrave the insert of the mold. And in the right-hand side, we can see the final product in the market, in this case, the cup of Gianfranco Ferreluomo, and the mold insert already engraved using this technology, the nanosecond laser technology. Here's a similar example. In this case, we can see a texturized insert for Surlyn bottle, plastic injected material inside this mold, and the final plastic part. And some other examples. You can find a lot of examples in the market, a hairbrush, for example, these tetins. So we can even engrave inside cavities. Thanks to these 5 axes of the machines, we have no limitation in terms of surface. And some other examples. In the right-hand side, we can see Nina Ricci L'Ecstasy, imitation textile texture, even inside the cavity, as explained. Not to halves, but directly inside. And then in this example, we can see that there is really no limit in terms of design. So this image is taken from an illustrator by hand. Then we separated the different layers and to be able to engrave differently each layer. So we can see in this image 3D engraving, homogeneous depth texture, progressive depth texture, even degressive roughness density to achieve this beautiful effect on the sky of the image. And in this case, everything is done with a nanosecond laser except the light diffraction texture. As we can see, there are some colors here. This is because there is a nano microstructure created here, engraved in the mold. Plastic is injected there, and the plastic copies this micro and nano structure. So that's why we can achieve those colors in the final injected part. This is an example for a cup, standard cup for water, for example, where we can engrave everything with the laser, the grooves, the textures, the engraving, everything. One stack in the machine and very efficient. Here's a small case study that we did some time ago for the Land Rover Defender, which is right now in the market. And in this case, this is a design texture for a functional purpose. Why? Because our customer asked us the possibility to imitate brushed aluminum mold to avoid metallic part because of a new position of the radar. In this case, radar of the car was placed behind the logo, and that's why metallic part was not allowed. We analyzed using confocal microscope, imitated the desired texture, and then engraved with a nanosecond in the mold, and we can see here the final part, which is in the market right now. Some other example, in the case of the Seat Leon 2020, for lighting in this case, there was the initial idea of the customer. We offered them the render, accepted the proposal, then we engraved the mold insert, and we can see here as well the final, for lighting effect in this case, the final part we can see in this Seat Leon 2020. So until here, we have spoken most of all for a nanosecond laser. And we are going to begin to speak about, nanosecond laser. We are going to begin right now to speak about femtosecond laser. So which is the difference? As you may know, femtosecond laser is an ultra-short pulse duration laser. So thanks to this cold, they say, ablation over the material, we can achieve a clean with very sharp edges and absolutely burr-free micromilling with very high quality surface finishing. So everything that we have seen until now, there was burr there. But if the texture is for design purpose, you don't even care about burr because the burr is so small that the human eye cannot see it. But if we want to think about creating some functionality in the part, the burr it is important because we need to control microns, something that is not possible with the nanosecond laser, but it is possible with the femtosecond laser. So finally, what this new technology, this femtosecond laser in 5-axis, let us? It let us engrave standard tool, completely standard mold inserts in a way that was not possible before. So achieving smaller details than ever before. If we compare with conventional technologies like milling machine, die sinking EDM, and so on, we can achieve down to 10 times smaller details than ever. And I insist in conventional tool, conventional parts, conventional inserts. So sometimes we work on mold, engraving the mold, plastic is injected and you can find the functionality there. And sometimes we engrave directly final parts that can be prostheses, can be prototypes, can be special parts that require micro-milling, etc. In this case, we can see some functional texturing that we can achieve, some pitchkin effect, for example, some velvet effect in the plastic without any post-process coating, whatever, just because of the effect of engraving, of injecting Rover plastic, for example, in texturized mold, soft touch effect in the plastic thanks to the texture in the mold, or even increasing the anti-scratch properties of the plastic just because we engrave some texture in the mold that then the plastic replicates it. This is a comparison, a study we did time ago, comparing chemical etching with laser for anti-scratch purposes, where we see that the laser is always having a better impact than the chemical etching. Some other functionality, hydrophobicity, to increase the contact angle of the water dot compared with the plastic. And what we are engraving is the image we can see here in the confocal microscope, around 20 micron depth and 20 micron pitch. Of course, with nanosecond is impossible because just the burr is bigger than that. Self-lubrication texture for tool, or osseointegration texture for implants, spin plate, hip joint, dental implants, with some benefits compared to conventional technologies. For this purpose, it could be more cost-effective solution. It is a digital process, so it is a control texturing, no part masking required, possibility of different textures with one setup, 100% reproducible, etc. Some other benefits that we can find using this technology for this purpose. About lighting, we can have the light diffusion properties, avoiding expensive diffusion materials just because the texture that we engrave in the mold. And regarding microstructuring, if you compare the image here with the fingerprint, you can imagine how small it is and how clean the engraving is. Some other examples for optical parts. Here we can see the high quality surface, the high quality finishing. We can leave very smooth roughness, even it is shining. And in the right-hand side, very small structure, just 200 micron pitch and the complete pyramid there. Some other examples in micro-optics, for example, we can achieve absolutely free-form micro-optics. We can even see here Fresnel lens of 60 micron pitch. And as we spoke before, not just in small flat surfaces. This technology is applicable to all kind of standard molds with no need of any change. And here we can see production insert with hundreds of micro ovals engraved in over this 3D shape. In the case here of the SET Ibiza 2021, we engraved these micro prisms because SEAT engineers, what they wanted and designers was to achieve those effects with the light in the air vents. This is a specific case for our customer Disalux in the Basque Country in Spain. And they needed a very special, a very strange, let's say, micro milling, microstructure to achieve very specific purpose with the light. In fact, we can see here the mold insert, the plastic injection. You can imagine how small those details are. And we can see the comparison between simulated value in the simulators, in the programs, compared with measured value over final injected part. As you can see, it's very close, and it's close even. Plastic is not replicating 100% of the microstructure because there's the injection process, of course. But even that, we can see that the effect is very, very close about what they wanted to achieve. Or in this case, microstructuring for a light guide applications. We can microstructure a mold, inject plastic, and have this homogeneity for light guides just with one LED on the side. This is a specific example, a small case study that we for the Cupra Tavascan. So in this case, Cupra engineers and designers wanted to have this light curtain parts in the tail lamp of the car. So the idea is to be able to work in 3 dimensions, to be able to design inside the tail lamp. So to achieve this purpose in an homogeneous way, of course, the LED is coming from the top, and there are thousands of microprisms engraved on those parts to achieve this light curtain in an homogeneous way to the eyes. Then a last case study in medical industry, in this case for microfluidics. In this case, our customers ask us the possibility to directly engrave glass for a microfluidic chip for liquid biopsy for tumoral cells. So we engraved the glass, they did the validation test with PS particles to mimic tumoral cell separation, and the micropattern was perfectly functional, and the microfluidic device worked properly. So this is what I wanted to show, some applications in the industry, both in final part or in mold, using both technologies. And please feel free to ask me any question. I will be happy to help. Thank you so much.
Raul.garcia@microrelleus.com, asking anything about laser surface structuring, or simply schedule having a beer with him because he's one of the nicest people in the EPIC network. Raul, first of all, congratulations. What you're doing is simply amazing and just beautiful. The butterfly was just beautiful, out of this world. We have a lot of questions for you. The first one is from Professor Aníbal Tapia. He is actually coming all the way from Portugal, from the Escuela Superior Politécnica del Litoral. And actually, he has a question: in what type of materials can this technology be applied?
Okay, in the case of nanosecond laser, we are more limited to steel or similar to achieve good result because the wavelength is infrared. In the case of femtosecond laser, it's infrared as well, what we use. But because of this cold, let's say, ablation of the femtosecond laser, we can engrave over any material. So it depends on the quality they need. For some materials work better than for others. But we never found a material that is not able to be engraved using the femtosecond laser.
The next question comes from the company ITF Technologies, one of the specialty fiber companies that we have in our network. The question is from Martin Otto. He's actually wondering, is surface preparation conditioning prior to microstructuring critical?
No, surface preparation, I don't know if he means in terms of programming or the preparation of the surface of the steel or the part. Well, programming is not a problem. There's a procedure. That's it. And then it is very important that the part is exactly the same than the 3D file that we have, of course, because we have to explain the machine where the part is and how to fix the machine. So laser is going to somewhere that we predefine. We before explain it, where to go and how to do it. But of course, the 3D file needs to be the same than the real part that we have in the machine.
Raul, stop sharing the screen if you will, so we can see both of us together, because I really like when I'm next to you on the screen. The next question is coming all the way from Greece. This is a startup, one of the most innovative startups in surface structuring. The company is called Biomimetic. Evangelos Koulas is the founder of Biomimetic. Evangelos is wondering, do you see functional micro nano textures, functional surfaces coming into the market soon? And I share this concern. What is the bottleneck?
The main bottleneck is is being able to say for how long these structures are going to work. We have some functional structures in the market, in real products in the market, but of course it is a risk that the customer has to take, because, for example, hydrophobicity, we can create some texture for hydrophobicity purpose, and we know that tomorrow will work, but we don't know if the life of this structure will be longer than the life of the product. So if it is not, it makes no sense. So of course, this is a risk that the customer needs to take. But if we are speaking about bigger structures like 200 micron, 400 micron, we never had a problem before. The problem comes with very small structures, 20, 40, 30 microns, or even smaller in the nano range, that in that case, we don't know.
The dream is to have these kind of surfaces in clinics, to have them in planes, to have them in automotive. If you, for some of these surfaces, the antibacterial and the easy to clean, do you have a dream? What is your wish time to market? When do you think we are going to see this in consumer products in larger surfaces?
This is more delicate, more complicated, because if we're speaking about antibacterial micro or nanostructure, of course, it's what I explained before about the life of the texture. We need a texture that we need to be sure that it will work more than the life of the product. And in this case, as far as we know, we are not very in this kind of structures, but for the moment, as far as we know, it is not yet in the market, so there's more R&D needed after that.
One final question is coming this time, yes, from Portugal, from the company Peak Advance. Ricardo Bastos, he was very curious about your silicon substrate, and he says, any kind of application that you foresee for such patterning on the silicon substrate?
The silicon substrate, you mean for the microfluidic, I assume?
Yes.
Well, in this case, it's a customer always that send us the material. We have a lot of requests about, can you engrave this material or this other? Because they are the ones that know that some material is good for their application. So what we do always is just send your material. We are going to do a test, and we tell you feedback, and that's it. So that's why I told before that we never found a material not being able to engrave using femtosecond laser. But it's always the customer who decides the material, and so on. So they are the ones that have the know-how about materials.
The final question is coming from Mihai Muresan, and he has a very good question. How do you clean a nanostructure structure?
Okay, we are not in the nano range. We are in the micro range. In fact, the range that we feel comfortable is dozens of microns. So it is not our case. In the case of the microstructure, acetone, alcohol, and cotton.
Thank you very much for that final answer. I loved it. Acetone, alcohol, and patience. And I would like to say to everyone, get in touch with Raul, because what he's doing is truly spectacular. And this is one of the success stories that made me excited and made my job exciting. Raul, muchísimas gracias.